In this lesson, we're going to look at a more complicated question in trigonometry where you don't know the ratio and you're not automatically given a right angle triangle. So let's look at the question. ABCD is a rhombus. We have a diagram here, given 7 in this diagonal, and we're told that this length and this length are the same size. We should know that from the rhombus anyway, and it is 12 along from A to C. Calculate the size of shaded angle BAD. Now, shaded angle BAD, start at B, you go to A, and then down to D. So it's this angle in here. Now, the mistake that people make is they try to calculate that angle straight away, which you can't actually do. What you can do is you can try to pick out a right angle triangle from this, because trigonometry at the moment only works with right angle triangles. Now, if you look at this part up here, you can see that there's a right angle triangle there. If I click on that, this is the right angle triangle that we're going to use, this one here. Now, this right angle triangle, if you look at this part, is the angle in this is actually half of angle BAD. These two angles in a rhombus are exactly the same. This top part here, I'll just mark that. This bit here and this bit here are exactly the same size. So if we work out the top one in the yellow triangle, then we can just double it to find the total here, which is B to A to D. So the first thing, we want to draw this wee right angle triangle out. We want to put a 7 here, and we want to find another length on the triangle. We need 2 lengths in the triangle to work out an angle. Now, there's no way of working this one up and down the way, but we can see here this bit across is half of the 12 all the way across, and these two bits are exactly the same size, so this must be 6 along the way. So we can draw a wee triangle out here and label the sides. That's your opposite angle, hypotenuse, opposite the right angle, and 6 along the bottom here, which we just worked out. So remember, always draw your triangle out and label it. Once you've done that, you need to work out what to use, sine, cos or tan. So if you look at the triangle here, we've given information next to A, the adjacent side, which is 6. So I'll highlight the A and I'll give the A's up here a wee tick. So A here needs a tick and A here needs a tick. Now, the other information on the triangle we've been given is the hypotenuse side here, which is 7. We've got no opposite side, so we're not interested in the opposite at all, but we have got the hypotenuse. So we'll tick the hypotenuse side here, and we'll tick the hypotenuse side here. So you will notice there's 2 ticks next to cos, so it's the cosine ratio that we'll use. So cos of x, just call the angle x here. We don't know what it's called, but we'll just make it up. We'll just put an x in there. And, well, you suppose you could call it BAC if you wanted to, but I would just call it an x for simplicity. So cos is equal to adjacent over hypotenuse. So adjacent over hypotenuse. Fill in the information. You know the adjacent is 6 and the hypotenuse is 7. So cos x is 6 over 7. And remember, to work out x, you do 6 divided by 7 and an inverse cos. So inverse cos 6 divided by 7, and if you type that into your calculator with the brackets, you will get 31 degrees. Now this part here, this top part, is 31 degrees, but we want the angle BAD. So as mentioned earlier, we really want all of that all the way around. So you just basically double this angle. Now, don't write x equals 31 times 2. Start again and say angle BAD equals 31 times 2, which is 62 degrees. And that's your final answer.